So the problem gives us this cubic polynomial, and it says that it has three roots, which are cosine of 2 pi over 7, 4 pi over 7, and 6 pi over 7. And then we're just asked to find the products of these coefficients here. Okay, so first of all, by Vieta's formulas, we know that, like, we can, so let's try to find each number individually first. So let's first start off with C, because C seems like the simplest, right? By Vieta's, it's just the product of all these cosines. The cosine of 2 pi over 7 times cosine of 4 pi over 7 times cosine of 6 pi over 7. Okay, so how are we going to evaluate this? Well, we don't know how to exactly work with angles like these, right? Because 2 pi over 7 is not something we would find in like a generic triangle that we know we can work with. So we have to do something a little smarter. So what can we do? Well, first off, let's look at cosine of 6 pi for a second. So we know that basically cosine of pi minus x is equal to negative cosine x, right? That this is one of the identities of cosine. So we can say that cosine of 6 pi over 7 is just going to be negative cosine pi over 7. It just makes it kind of simpler, so that we have like consecutive powers of 2 instead of just like adding 2 to each one. So let's just write that out. Okay, so now we have these consecutive powers of 2 being multiplied to pi over 7, and we have all these cosines. So what can we do here now, right? We can't like manually bash these out. Well, what we can do is we can maybe try to incorporate the double angle formula somewhere. So like in the double angle formula for sine, we have like 2 sine of a cosine a is equal to sine of 2a, right? 2 sine of a cosine a equals sine of 2a. So what if I took a sine of pi over 7 and I multiplied that with 2, and then I put that here, and then I can simplify that to sine of 2 pi over 7. So let's do that. So let's see. We can do, so I can take 2 cosine pi over 7 times sine of pi over 7 times cosine 2 pi over 7 times cosine 4 pi over 7. But I also have to divide again, so so that this stays equal. So negative 1 over 2 sine pi over 7. And okay, so this evaluates basically to sine of 2 pi over 7. Aha, so we have a sine of 2 pi over 7 here, and we have a sine of 2 pi over 7 here. So we can basically just keep applying the double angle formula over and over and over again, right? And then we're just going to get a fraction here and a sign on top, and then we can probably simplify that a little bit more. So let's do that. Let's do that now. Okay, so we already have like a sine of 2 pi over 7 cosine 2 pi over 7, so we can just multiply by 2 here, multiply by 2 here, and then we'll get c is equal to negative 1 over 4 sine pi over 7 times sine 4 pi over 7 cosine 4 pi over 7. And then again, we have two of the same angles, so we'll multiply here, and we'll divide here. Okay, so now we have sine of 8 pi over 7, and then we have the sine of pi over 7 here. And so now we can basically just subtract from this inside here. We can subtract 7 pi over 7, which is just pi, right? And since since sine is an odd function, we'll just have a negative out here. So sine of 8 pi over 7 is just negative sine pi over 7, right? So negative sine pi over 7. These sines pi over 7s cancel out, and so we're just left with 1 over 8. So we found the value of c. So that's one of the coefficients. Okay, so now let's move on to the other simpler one, which is a. Because b is like probably the most complicated. Yeah, definitely the most complicated, because we have to find the product of pairs. So let's start off with, let's do the simpler one now. So a is just the sum of all these cosines, right? Cosine 2 pi over 7 plus cosine 4 pi over 7 plus cosine 6 pi over 7. Okay, now this is going to be really, really hard to bash out like with just calculations, right? So we have to probably like do something a little bit smarter. So we see like angles and we see 7 in the denominator. So that gets us thinking about roots of unity. And we can probably be thinking about like the 7th roots of unity, because we have the 7 on the denominator. So roots of unity, by the way, are like, so the square root, the nth root of 1, right? Like all the numbers that multiply, that when taken to the power of n, are equal to 1. So like the 7th roots of unity are going to be, it's going to be the 7 complex roots of the 7th root of 1. So how are we going to find, so Euler's formula allows us to find those roots, right? Which is r e to the power of I theta is equal to r cosine theta plus I sine theta. Since we're dealing with 1, we can just disregard the r since it's going to be equal to 1 anyway. So e to the power of I theta equals cosine theta plus I sine theta. Okay, so now so what are the 7th roots of unity, right? Well, so what's the 0th root of unity, right? So cosine of what equals 0? Well, cosine of 2 pi equals 1. So theta would equal 2. So if we have like e to the power of I 2 pi, that's just going to be equal to 1. So for the 7th roots of unity, we just have to take the exponent and divide it by 7. So e to the power of 2 pi over 7. But remember, there are 7 roots, right? So what we can do is we can take 2 pi over 7, and then we can continue adding on 2 pi's. This is De Moivre's theorem, by the way. De Moivre's theorem, which basically, you can do this for k equals 0 through 6, and then you'll get those 7 roots of unity. Okay, so with that information, we can pretty easily just like list out the 7 roots of unity. Those are going to be e to the 0, which is just 1, e to the power of I, 2 pi over 7, e to the power of I, 4 pi over 7, etc. All the way until e to the power of I, 12 pi over 7. Okay, so these are the 7 roots of unity. Well, now what? Well, okay, so let's look at 2 pairs so that their angles add up to pi. So like 2 and 12 are one pair, 4 and 10 would be the other pair. Like they're always going to be pairs that add up to pi, right? So e to the power of I times 2 pi over 7 plus e to the power of I times 12 pi over 7. Well, okay, so we know that cosine of 2 pi minus x is just going to be the same as cosine of x, right? Because the period of cosine of x is 2 pi, and since it's an even function, we're not going to have a negative anywhere. But the thing for sine, which is attached to that complex part, is that sine of 2 pi minus x is actually the negative, is equal to negative sine of x. So notice the relationship between 12 pi over 7 and 2 pi over 7. 12 pi over 7 is 2 pi minus 2 pi over 7. So basically, we're just going to have so the sum of e to the power of I times 2 pi over 7, let me actually just write it. Let me just write it so it's more clear. Okay, so e to the power of I times 2 pi over 7 plus e to the power of I times 12 pi over 7. Again, so this is just 2 pi, this is 2 pi minus 2 pi over 7, and this is just 2 pi over 7. So cosine stays the same. So we have 2 cosine 2 pi over 7. So 2 cosine 2 pi over 7. And then by Euler's formula, we'll have a sine of 2 pi over 7 times I, but we'll also subtract that off because this is just going to be the pi added onto that, right? So plus sine of 2 pi over 7 times I minus sine 2 pi over 7 times I. So this is just 2 cosine 2 pi over 7, right? So these are just irrelevant, they make 0. So this is really useful now. So every pair that adds up to 2 pi will sum to like that angle times 2 cosine. Okay, so with that information, we can say, so we have 1 plus e to the 0. So these are the sum of the 7 roots of unity, right? So let's dot dot dot. So what is this going to be? Well, these are the roots of the polynomial z to the 7 minus 1 equals 0. And by Vieta's, the sum is just going to be equal to 0. So this is equal to 0. But, so we don't really care. Oh wait, I included 1 twice, my bad. E to 0 is fine. So we don't really care about 1, right? Because it doesn't have an angle involved, it's just 0. And what we originally want to find is cosine 2 pi over 7 plus 4 pi over 7 plus 6 pi over 7, right? So we really only care about 6 of the roots. We don't really care about 1, because 1 is not, it has an angle of 0. So we can subtract 1, and so what we can say is basically 2 times cosine of 2 pi over 7, which is what we got from e to the power of 2 pi I over 7 plus e to the power of 12 pi I over 7. And you can do this with all the other pairs. So cosine of 4 pi over 7 plus cosine of 6 pi over 7 is going to be equal to 0 minus 1, which is just negative 1. So a, which is the sum of all these, is negative 1/2. So we found a. And if you're still like kind of confused on why this is true, like for the other angles, like for cosine of 4 pi over 7, the two e's that would add up to that, to 2 cosine 4 pi over 7, those would be e to the power of 4 pi I over 7 and e to the power of 10 pi I over 7. For cosine of 6 pi over 7 times 2, that would be e to the power of 6 pi I over 7 plus e to the power of 8 pi I over 7. So each pair adds up to twice of these cosines. So we got a. So we found a is equal to negative 1/2. Okay, so now comes the hardest part, which is b. So b is just going to be the products of pairs. So like cosine, this is b, right? So b, cosine 2 pi over 7 times cosine of 4 pi over 7 plus cosine 2 pi over 7 times cosine 6 pi over 7 plus cosine 4 pi over 7 times cosine 6 pi over 7. Again, we're not going to directly calculate this because this is going to be way too long. And there's actually a much smarter way to do this. Okay, so we can actually use the information we got by finding a. So we know the value of a, which is the sum of all these cosines, right? So let's use that to kind of help us maybe. So let's write out a, right? So cosine 2 pi over 7 plus cosine 4 pi over 7 plus cosine 6 pi over 7. Now, what we can do is we can square this expression. Since we know the value of a, this is 1/4, right? This whole thing is 1/4. But this is also going to be equal to cosine squared 2 pi over 7 plus cosine squared 4 pi over 7 plus cosine squared 6 pi over 7 plus 2b, right? Because b is just the product of the pairs. And this is equal to 1/4. Okay, so Now the main problem, actually, instead of finding that complex value for b, is finding what this sum is, all of the powers of 2 of this. So we can do another little smart trick here, right? We can use the double angle formula for cosine. So write cosine of 2x is equal to 2 cosine squared x minus 1. Okay, so then we can write cosine squared x in terms of cosine 2x. So we have cosine squared of x is equal to cosine of 2x plus 1 divided by 2. Okay, so let's just observe for a second, right? So cosine, actually this is really messy, hold on, let me clean things up a bit. Okay, so cosine squared of x equals cosine 2x plus 1 over 2. So what's cosine squared of 2 pi over 7? Well, that's cosine of 4 pi over 7 plus 1 over 2. Cosine squared of 4 pi over 7 is going to be cosine of 8 pi over 7 plus 1 over 2. So basically what we're doing is the sum of these is just going to be the sum of like, so it's just going to be like cosine 4 pi over 7 plus cosine 8 pi over 7 plus cosine 12 pi over 7. And then we're going to take all of this whole expression, divide it by 2 and add 1. But remember what we found earlier, is we can just take any pairs of these from the 6 roots of unity, excluding 1, and they're going to have to add up to 1/2, right? Negative 1/2, right? So the sum of all of this is actually just negative 1/2. Again, it's the same thing. So that was like the key thing to notice. So the sum of all of these squares is just the sum of all of those cosines, right? Which is also going to be negative 1/2. So that's the sum of all of, well, this isn't negative 1/2, my bad. The sum of cosine 4 pi over 7, 8 pi over 7, and 12 pi over 7 is negative 1/2. So then that means that this is going to be negative 1/2 plus 1 over 2. Negative 1/2 plus 3 over 2, because there are 3 of them. So let's write that out now. Okay, so we have 1/2. Remember, we had to divide by 2. This was the negative 1/2, which was the sum of all cosines. Plus 1, plus 1, plus 1, which is plus 3, plus 2b equals 1/4. And so solving, we get b is also equal to negative 1/2. So cool, we found all values, we found a, b, and c, and so the product is just simply 1/2 squared times the value of c, which I believe was 1/8. So 1/4 times 1/8 is just going to be d, which is 1/32.